Thank you for joining our presentation. My name is Kodituwakku, and I'm a PhD candidate in computer engineering, concentrating in cybersecurity at the University of Tennessee, Knoxville. The work we're presenting today has been developed as a part of my PhD dissertation in collaboration with Eboni Thamavong, my co-presenter today, and Tim Shimiel from SEI. Prior to starting my PhD, I worked on a National Science Foundation-funded project to develop a real-time network situational awareness and flow analysis platform for large-scale networks such as universities and research centers. InSight platform was born as part of that, which is currently being used at multiple universities and research centers in US and abroad. My goal after graduation is to bring academic solutions and new perspectives to solve the problems in the industry.
My name is Eboni Thamavong. I currently work at Booz Allen Hamilton as a cyber threat intelligence professional. Before coming to Booz Allen, I worked at NSA in a managerial, analytic, and operational capacity. I recently finished my MBA, and I am most interested in the business of intelligence and making analysts' lives easier within it. I feel that our research is an important contribution to the cybersecurity and data science community, and that it has long-lasting impact. I want to thank FlowCon for the opportunity to present once again.
The goal of this research is to develop a system that can uniquely identify hosts in a network without relying on addresses such as MAC and IP, since they can be easily spoofed and are not consistent. So we wanted to find a better identifier that is not self-proclaimed or can be changed by the host itself. We looked into the host behavior as well as host intrinsic characteristics, and we developed a unique identifier that we call a host descriptor, or HD. HD is a statistical representative model rather than an arbitrary address. It describes the host and accumulates the MAC and IP addresses that it sees over time that the host was identified as. This information is made available for the security analysts in the HD table, or HDT, so that they can look up all the MAC and IP addresses the host used and their timestamps when the host was connected to the network. InSight Next Generation, or InSightNG, is the distributed sensor-based system that we developed to collect the necessary data, calculates the HDs per host, and then keeps track of each host. Using the system, we are able to detect address changing or address spoofing in real time. Flow data generated using this system that are tagged with the HD and other contextual information can be used to train statistical models with more accuracy compared to using traditional addresses in the flow data. This is beneficial in dynamic environments where there's no guarantee a host will use the same address at all times, as well as when addresses are spoofed for malicious purposes. It is trivial to change host addresses in most network environments, and the amount of manual work an analyst has to do to identify devices uniquely in the network does not scale well and is very time-consuming and can also cause missed events. Not all networks can enforce the installation of a software agent in all its client devices prior to joining the network in order to uniquely track them. So tracking behavior produces better results than addresses, since it is difficult to modify attack behavior. This presentation has 3 parts: the journey, how we got here; the mission, what we wanted to do and the goals; the work, how we achieved these goals. To start off, Eboni and I will give our perspectives on the motivation that includes practitioner point of view and the academic point of view. Then we give a quick recap of the previous work that we have done, of which you can see the screenshot on your right, the InSight open source visualization platform for flow data in real-time situational awareness and flow analysis. In the next section, Eboni will talk about the challenges a practitioner faces in the field, and I will talk about some of the challenges that I faced while developing InSightNG. And the screenshot that you see on your right is a visualization that we developed while we were analyzing the WRCCTC Cyber Defense Competition dataset. Based on this work and the lessons learned along the way, we define goals for InSightNG. In the final section, we talk about the methodology for achieving these goals and show a quick example, what InsightNG can do for an analyst to make their lives easier. Since this is an ongoing research, we will show you the current progress and what to expect in the coming months. And on your right, you can see a screenshot from one of our meetings with the collaborators and advisors developing this architecture. Then we will finish this presentation with the future work that are both applications and extensions that can be built upon InsightNG. When we talk about classification of objects, either physical or virtual, using statistical models, we require data that we can get from the environment that the object normally resides in. Then we can use appropriate learning algorithms to train models in order to classify them. Industry has access to their own data, which allows them to know the perfect ground truth as well as context. For academic purposes, though, researchers have to rely on either PCAP dumps or benchmark datasets. Benchmark datasets that are widely being used tend to be irrelevant and outdated. So we need flexible frameworks to generate our own data. And for that, we need network models to capture the data from. In order to capture a good enough dataset, we need to be able to tune the parameters and collect the right features for our application. These models and frameworks should not only be generic enough to be applied under a wide range of applications, but also representative of real-world networks. Assuming we get access to this data, we require data structures and statistical techniques to understand where each host lies in our feature space. Assuming we have the data we need, data structures and distance measurement techniques to understand the data, the fundamental challenge becomes uniquely identifying the objects, which in this case are the hosts. From data science perspective, if a host had multiple identifiers in the dataset, they will be treated as separate hosts, and it will result in separate models for the same host, which is not desirable. In the worst case, if IP addresses are shared among many hosts in the dataset, per-host modeling can result in inconsistent or unstable models. This will limit research applications when conventional addresses are being used. There are synthetic data generators, however, this research focuses on building an architecture to collect data from actual networks that are either physical or virtual. We also wanted to achieve this goal without modifying the devices, the network protocols, or the network infrastructure, such as switches or routers.
Because threats are constantly morphing, the need for a persistent identifier is paramount. MAC addresses and IP addresses can be spoofed, and domain ownership can be changed or subverted. This makes the identification and attribution of malicious activity hard. There is a need to improve autonomy and efficiency. Analysts need help prioritizing which threats are the most important, having a quantifiable score that aids in that prioritization, and of course, data visualization that includes host characteristics that are actionable. Recently, Angel and I were invited to present at a SEI webcast that highlighted our merging of two worlds between data science and cybersecurity. Overall, we wanted to show that through collaboration and understanding the motivations of academics and those of us who work in industry, we could bring fresh perspective in this field. My perspective is that industry analysts are under a lot of pressure to produce. This doesn't usually leave a lot of time for thought leadership, research. We often don't get to work with our data science community or bring their problems to them very often, so I believe there's a missed opportunity to help each other out. We in industry can provide them real-world context, and they can take the time to work on longer-term problems that will help us overall.
My previous work includes Insight 2.0, a real-time situational awareness and flow analytics platform. It is built for scalability and extendability providing access to third-party modules and data export functionality for external data analysis tools. We have been presenting our work at FlowCon since 2018, and our recent journal paper outlines the system architecture and the case studies from its various deployments of InSightNG. Let's talk about some of the lessons we learned from our previous work, feedback from deployments, and my literature review for my PhD. Also, we look at case studies that we performed from our previous InSightNG deployments, data analysis from WRCCDC competition, as well as developing deep learning models to detect compromised hosts using enriched flow data from InSightNG. All that helped us refine the goals for this research. It is apparent that we need specialized datasets for specific applications. However, generating data can be challenging, especially from real-world networks. Applications of models developed using benchmark datasets can be challenging and may have limited use in real world. KDD and its variants are very popular among cybersecurity researchers. These datasets can be excellent for developing competitive models, and their high citation count allows easy performance comparisons, which is critical when writing papers. However, for industry applications, relevance of the models is far more important than accuracy figures on paper. To our knowledge, there does not exist a publicly accessible dataset or a framework to generate such data that includes both host and network features. A system to generate data with relevant features at the subnet level can benefit the industry more than a set of parameters for a machine learning model specific to a benchmark dataset. Industry as well as academia can continuously benefit from such a system, since it will allow network administrators and researchers to generate their own data to conduct their own research. Since machine learning tools are far more accessible and available, they can use this data to create their own model with ease. Eboni will start this section discussing the challenges a practitioner faces when analyzing the flow data, especially when addresses are inconsistent. Then I will follow up with technical challenges I faced when developing InSightNG platform.
Day to day, analysts are inundated with lots of data, competing priorities depending on the political needs of the organization, and still have to present conclusions whether or not the data is complete. Additionally, threats are constantly morphing and require a variety of skills within the team, both technical and non-technical. There's now a lot of focus on proactivity within threat intelligence and to get at unknown unknowns. But the reality is that this is a challenging process, and analysts have a tough time keeping up. What they need are the right set of tools that makes analysis easier, and analysts can spend more time doing analysis and less time collecting.
In order to detect spoofing, we needed a distributed knowledge system that collects information from different subnets, but makes them available centrally. Such a system would need to span different departments, geographical locations, so that it can track hosts, generate HDs, share them, visualize flow data belonging to a set of HDs, and analyst needs to explore for more information. Furthermore, the system should be able to handle both host and network data at the same time. Such a system should not change the network infrastructure, should not enforce the installation of software agents, should collect data at the subnet level, capturing the layer 2 peer-to-peer traffic. Data structures based on tensors allow extendability and efficient computation and storage. The distributed sensor network should employ edge computing architecture consisting of low-power sensor nodes for data collection as well as creating the HD snapshots. A centralized analysis engine will handle spoofing detection, indexing of the enriched flow data, and respond to the analyst queries in real-time visualizations. A secure overlay virtual network will allow passing of the HD snapshots and control signals among the nodes in the system. Such a system should also employ strong anonymization techniques to preserve user privacy. With our experience and the lessons learned, we define goals for our current research. We require data from each subnet. We require the creation of unique host identifier that uses both host telemetry and its network behavior. We need to develop the sensor as well as the core nodes that perform these tasks. A new data structure is necessary to allow computation as well as storage of HDs efficiently. After HDs are created and stored, we require a statistical distance measurement technique that will be used to detect spoofing as well as cluster these devices based on behavior and characteristics. Furthermore, these HDs can be shared among partners of the Federation if the system is deployed across different organizations.
Automated detection methods are useful, but they cannot detect all breaches. Adversaries adapt well to most automated detection methods. I see this research as a way to advance timeliness for SOC operations, as administrators can be alerted a lot sooner to anomalous activity. Given that the average time to identify an adversary within the enterprise network was 191 days, any tool that can shorten that time is highly beneficial. Having a way to correlate anomalous activity with current observed activity would vastly save time for analysts. Giving spoof HDs along with current MAC, IP, and domains gives an administrator an advantage because the devices can be tracked no matter where they are located on the network.
In the final section, we talk about some of the technical details, functional examples, current progress, and the plans for the immediate future. Finally, we conclude this presentation with applications of this research as well as potential extensions. We developed a model network that consists of 4 VLANs, including ClearNet, Management, DMZ, and Site-to-Site VPN, with common services running such as web and mail. We implemented this on Cisco Viral. The sensor node performs data collection as well as calculation of the HDs per host, and then it sends it to the core node for further processing. At the core node, we calculate the intra-HD distance, or IHDD, to detect spoofing. Then we will append the snapshot to the HD tensor to keep the model up to date with the host behavior. If any of the addresses are changed, they will be updated in the HD table, or HDT. As we discovered, the host descriptor is a statistical model describing the behavior of the host. HD snapshot is created at this sensor node and sent to the core. The core updates the HD with the snapshot. HDT keeps the known addresses of the host and is accessible from the core, centrally available for the security analysts. Intra-HD distance, or IHDD, is a multivariate distance between 2 HDs, which is used to detect spoofing and cluster similarly behaving devices. IHDD is calculated using numerical and categorical information in the HDs. HD table, or HDT, is analogous to the ARP table, or the routing table. It maps known IP and MAC addresses to the HD and the timestamps they were observed. An analyst can either look up IP or MAC at a given time and find the HD, or compare 2 different MAC or IP addresses to see if they belong to the same device. In this example, we look at host A, which connects to the network using MAC A. Since this is the first time that the host is seen by InSightNG, it calculates its HD, the HDA, and it inserts MAC A to the HDT at the time TA. Consider at time TB, host A changes its MAC address to MAC B. Then MAC B is added to the HDT as well as to HDA with the timestamp TB. Traditionally, when an analyst wants to query all the network flows belonging to a host, in this case host A, they will need to manually find all MAC addresses or IPs and the timestamps they used and query them individually. However, this can result in incomplete data if the analyst does not have the knowledge of all the MAC addresses. Instead, if the analyst used the HDT to query one of the known MACs, then the HDT provides all its other addresses such as IP and MAC addresses. At this stage, we have completed the network design, implementation, network and host features selection, host telemetry collection techniques, and HG templates, what features go in there, numerical and categorical features, etc. Traffic model selection has been performed as well using ICOM complexity criterion. Distance calculation methodology, the intra-HG distance, is also defined. Host data generation will be performed using similar probability density function observed in real-world network flow data that we've seen before. And then we will execute the following 6 scenarios and collect data for case studies. Spoofing, MAC, IP, or domain, VPN usage, rogue bridge device or multiple users per device, host compromise that does not include network flows, either using phishing attack or physical intrusion, physical movement between the subnets, since we have access to layer 2 information as well as the location we can track users between different subnets. Finally, we will evaluate the performance in each scenario. Future work for InSightNG includes deployments and federation. We plan to deploy and test performance at scale, share individual threat signatures in the form of HDs with the other federated sites, then develop artificial intelligence and machine learning models with the data generated. Train models to detect various types of attacks in real time. We have flexible data export functionality at the core that researchers can use to use external tools to develop models. And we also plan to tag network flows with the HDs in real time, which requires two-way communication with the core for verification. Finally, visualizations can be provided from a central location for network administrators, as well as provide notifications of current physical location of the spoofed device. You can reach us and read more about our work with the following contact information. We have our Discord group as well. Since you all have Discord accounts, I warmly welcome to join our Discord group to have conversations. Thank you for attending our presentation once again.
Eboni and Angel, welcome to the live Q&A. Thank you for sharing your findings. We got lots of great questions coming in, so we're going to dive right into them. First one, I'm going to give this one to you, Eboni, asking, what kind of flow data does InSighting accept? So, Eboni?
Actually, if it's okay, I will punt that one to Angel.
Absolutely.
Currently, we are using Argus data because it's open source and have a great client-server architecture. So currently Argus, but in theory, in general, we can experiment with others. But so far, we've only experimented with Argus.
And next we got, what kind of data sets can I create using InSighting? So we'll keep with you on that one, Angel.
So when you create data sets, the traditional data sets, the problem is it's hard to track the host uniquely. So the HDs that we tag each host with, each flow with, enables us to create any kind of data set, especially when there's from adversarial networks, such as CTF competitions and breach data. So it doesn't require you to track the host by installing agents in each host. So you can pretty much create from any scenario. It gives more possibilities, more scenarios you can generate data from and create data sets with.
Next we have from James asking, can you describe what features you are using?
So I haven't gone into details in this presentation, but it includes host as well as network data. For example, network side, everything Argus provides, and from the host side, the characteristics of host. For example, the operating system guesses, services running, ports open, and other kinds of information. There's a web server running, what's the what strings we can gather. Basically, anything you can get using a tool such as Nmap. will be in the host side of the features.
Okay, next we have, when you develop a statistical model for hosts, do you gain some insight into classifying hosts of similar users so you can identify abhorrent behavior from hosts that should have similar functions? And let me know if you need a repeat of that.
Yeah, so one of the applications of HDs and overall our system is to be able to get insights about the host itself. So definitely, I touch a little bit on this in the slides. So clustering hosts based on their behavior is one of the applications. So the short answer is yes. And compared to traditional flow data, we have much more information about the host, the intrinsic characteristics that we can use in conjunction with the network site of behavior to cluster the host that exhibit similar behavior.
Okay. Next, we have, what are some of the examples of machine learning models you can train using the flow data tagged with HDs?
This also connects with the earlier question. You can use clustering, unsupervised clustering, or you can have, if it's a specifically generated data set just for developing models, then you can have, you have a roadmap and you have a motivation. So you're going to classify this specific behavior from the host or their behavior. So in that case, I would suggest whatever is suitable. For example, if you're looking to cluster, then unsupervised algorithms. If you're looking to classify a specific behavior in the data, then you can use supervised models for that purpose.
Now I have a question for Eboni, just to bring her in here, of just the arrangement that you guys have. I know with Angel being in academia and you, Eboni, in industry, how did this collaboration come about?
It came about actually from FlowCon. So we met at FlowCon, maybe was it 2 years ago, Angel, or something like that. And I was giving a presentation on more of the managerial and practitioner side of like how to lead, analytic teams. And he was working more on this data. So one of the things that he asked was to be able to have a better understanding of what industry needs and what are the day-to-day challenges that practitioners actually have versus the academic side where you would, figure out, say, okay, this is, what I want to work on, not really sure if there's actually a good product market fit. So we collaborated to make sure that, the work that he was doing actually would make sense in the real world. So that's how this arrangement came to be.
Oh, terrific. So we got about a minute left. So if we can get a quick answer to this one, we'll squeeze this one in, asking, how would this differ from using an API to access centralized databases for tools provided by large enterprise vendors? Where does InSightNG live?
I think I can answer part of that, and I'll bounce back part of that to Eboni. So when we were discussing the goals for our research, we understood that there's a need for centralized access to the flow data from different departments. So Eboni will tell that how, from a practitioner point of view, how it's difficult to get data from different departments, different managerial organization lineage in a different and get access. That's a roadblock for analysts to get to their point. They have to work through a lot of managerial things. So the motivation is from that, but specific details, Eboni can elaborate a bit on that.
Yeah, so real quick, I'll just give an anecdotal example. I've worked on in an enterprise, a SOC enterprise, where you end up with different vendors owning different sets of data. So if we needed to go through and check, even though we had APIs calling in, if something went wrong, we needed to run scans or whatever, we wouldn't, for example, be able to do it. We'd have to call each individual vendor. So depending on what was going on, we wouldn't be able to have access to all the data. So the work that we've been doing is really to try to put it all in one place so it ends up not being so vendor agnostic, and because that's a really big challenge, especially when you're working in a crisis in the stock.
Great, thank you both. Thank you both very much. We appreciate you guys sharing your findings and research with us.